So hi guys, I will be discussing about t-test between two correlated means. But first of all, what is the definition of t-test between two correlated means? It is a test that checks whether there is any significant difference between the population means of two groups. And when do we use it anyway? It is used when two correlated groups of data are being compared. So we have the formula for the t-test. It is summation of d divided by n divided by sd divided by square root of n, where d stands for difference between pre-test and post-test, n stands for number of observations, and sd stands for standard deviation of the differences. Applicable when comparing two correlated means. For example, comparing the results of pre-test and the post-test administered to a group of individuals. The two tests must be the same. Our first example. Let's just say the pre-test and the post-test values are already given. So what we have to do is to find the difference between the two, such as 34 minus 45 is equals to negative 11. 23 minus 32 equals negative 9. 40 minus 46 equals negative 6, and so on. And once we have all those values, we can proceed to the next table, which is the d squared. All we have to do is square the value in the d column, such as negative 11 becomes 121. A tip and a really important rule: in order to find the squared value, you must always remember that regardless of the sign of the value, it is always positive when you square it. Such as negative 11, negative 9, it won't become negative 121, because when you square a number or a value, it becomes a positive. You have to find the positive always, okay? So like, we had to find all these values: 121, 81, 36, 676, 225, 9, 0, 1, 36, and 0. And now, we had to find the n. The n is just easy. You just have to count how many observations are there. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10. And now since we all have the values of d, we can now find the summation of d, which is a very simple step. You just have to add all of these without minding the negative signs. So when you do this, you just add 11 plus 9 plus 6 plus 26 plus 15 plus 3 plus 0 plus 1 plus 6 and 0, which is equal to 77. And we will do the same thing to the next column, which is the d squared. Just add all these columns, which is equals to 1185. What you have to do is to formulate the null hypothesis. So when you formulate a null hypothesis, it's usually and it's always a negative statement. So in this example, our null hypothesis would be there is no significant difference between the pre-test and the post-test. Next, we have to test whether the null hypothesis would be accepted or rejected. So let's find out. So we all know this is the formula, right? You just have to substitute those values since you already got them from the previous slide. But wait, what's SD? It's standard deviation. We all remember that there's no SD in the last previous slide, right? So we have to find it using this formula. N times summation of d squared minus summation of d squared divided by n times n minus 1. We already have the values of n, summation of d, and summation of d squared. So we all have to do is to substitute them in this formula. So we have 10 times 1185 minus 77 squared over 10 times 10 minus 1. So we have the answer of 65.729. But we don't stop there. We have to find its square root. Okay, to find SD, you need to square root that value. And the square root of 65.729 divided by square root of 10, which is 2.5646. Now, we can divide it directly to have the t. T is equals to 3 because if we would do like the full answer of this, it would like be 2.99, in which we have to round it off to 2 decimal places, in which results to 3. Now we can proceed to the next step, which is to find the degrees of freedom. N minus 1. N is 10, then minus 1 equals 9. Then find the 9th row, which is equal to 1.833. And now we have the value of CV and TV. So we can now compare which is greater or which is lesser. And we could really see that CV is greater than TV. Therefore, we can conclude that HO is rejected because the CV is higher than the TV. There is a significant difference between the pre-test and the post-test. So, example number 2. So, given that we already have the values of the before treatment and after treatment, we will do the same thing. Find the difference between the two. So 70 minus 70 is 0. 89 minus 78 equals 11. 90 minus 89 is 1. 89 minus 84 is 5. 78 minus 76 equals 2. 68 minus 89 equals negative 24. 56 minus 76 equals negative 20. 89 minus 65 equals 24. 98 minus 70 equals 28. 77 minus 89 equals negative 12. 70 minus 90 equals negative 20. So we just subtracted both of them. So the next thing we have to do is to find the square. We just have to find the square of that value. So 0, when you square it, it's just 0. 11 equals 11 squared is 121, then 1. 5 equals 25, 2, 4. 24 is 576. 20 squared is 400. 24 squared is 576. And 28 is 784. Negative 12 squared is 144. Negative 20 squared is 400. So we have to find the n, which is very easy. Just need to count how many observations are there. So the n is 11. And since we already have all these values in the D column, we can now find the summation by adding all of them, which is the summation of D is equals to 147. And we will do the same thing to the next column, which is the D squared. So just add all the values, and summation of D squared is equals to 3031. Remember those values, okay? So we can now formulate our null hypothesis. There is no significant difference between the before treatment and after treatment. Then we have to test the null hypothesis using this formula. And now, do the same thing to find SD. We need to use this formula, then substitute those values, and now we have 106.65. Then find its square root, which is 10.33. Now we already have the value of the SD, which is 10.33. Now divide this 147 divided by 11 and divide it by 10.33 divided by the square root of 11. And we now have the value of t, which is 41.62. Now we can find the degrees of freedom using this formula. N minus 1. 11 minus 1 equals to 10, in which you need to find the 10th row of your table, which is 1.812. You have the value of CV and TV, which is CV is 41.62 and TV is 1.812. We can see the huge difference, and we could really say that CV is greater than TV. So we can conclude that the HO is rejected because CV is greater than TV. There is a significant difference between before and after treatment. So all you have to remember is HRLA. If CV is higher, the null hypothesis is rejected. If the CV is lower, the null hypothesis is accepted. So now we have the third example. Given that pre-test and post-test values are already given, all we have to do is to find the difference between the two. So doing the same thing, subtract post-test from pre-test. So like 3 minus 5 equals -2, and do the same thing for all the values. And now, n is equals to 15, because there are 15 observations. Then since we already have the values of D, then all we have to do is add all of them in order to find the summation, which is equal to 42. And after that, square those values in the D column to find the square. And we have 4 plus 1 and so on and so forth, which is equal to 170. It's our null hypothesis again. So there is no significant difference between the pre-test and post-test. Now we have to test our null hypothesis. Use the formula again and find the SD by substituting those values in this formula, which equals to 1.93. So we already have the SD, so we can substitute it in the formula of T. And the answer is 5.62. We just have to make it step by step, such as 42 divided by 15, you have the answer. And divided by 1.93 divided by square root of 15, you have the answer. And then you could just divide both of them to have 5.62. 5.62 is also our computed value. So now we have the computed value, we can now proceed to the next step, which is to find the degree of freedom. And n minus 1. N is 15, subtract 1 from it, it becomes 14. So base it on the table, find the 14th row, and it is 1.761. So now we have the values of CV and TV. CV is 5.62 and TV is 1.761. And we could compare, and CV is greater than TV. So we can conclude that the HO is rejected because CV is greater than TV. There is a significant difference between pre-test and post-test. Ta-da! The end. I hope you understood, and I hope I made things clear. And thank you for watching. Have a good day.